Hello everyone, so today we are going to start our short unit on polynomials, and it's going to go back to what we've kind of covered in the past, which is how to combine like terms, which is adding and subtracting regular numbers or adding and subtracting numbers with the variable x, for example. But now we're going to incorporate adding variables terms with higher powers like 5x squared combined with 9x squared. The general idea is the same. You combine things that have the same letter and the same power. So let's get into the actual definition of a polynomial. So polynomial is just mathematical expression, has numbers, letters, exponents, and so on, consisting of a sum of terms. So when we have multiple terms added to each other, and each term or each piece of the polynomial has a number multiplied by a power. Again, when I say power, I mean a variable with an integer exponent, a whole number. Remember, the word integer means whole number. So the exponent must be a whole number, no fractions, no decimals, nothing of the sort. So let's look at an example of a polynomial. So here is a variable term. So this is a piece of a polynomial, or you can say it's an entire polynomial. It's 5x cubed, or to the power of 3. If I add another term to it, this is now a polynomial. It has more than one term. We have minus 2x squared, and I can keep adding more terms to it, like 8x and minus 6. So this is a polynomial with 4 individual pieces, or we call them 4 terms. So this is a polynomial. Now, let's go ahead and look at some examples of things that are not polynomials. The expression 9x to the negative 5th power, it's not a polynomial. So again, for polynomials, the powers must be positive, not negative. Or here's another example, 7x to the 1/3. Again, powers must be integers, whole numbers, not fractions or decimals or anything else other than a whole number. All right, so now that we kind of have the definition down, let's go ahead and define some words, and some words I may have already used, like the word term. So each part of a polynomial is considered the term. The way we separate terms are by the symbols plus and minus. So the plus sign or the minus sign starts the next term, and that sign belongs to the term. Pause as needed since I'm going to keep on going. The coefficient is the number, the big number that is part of the term. So how many of the x's do I have? So like it's a 7x cubed. So the number multiplied to the variable, the big number in front of the letter, that's the coefficient. Now we have several types of polynomials that are used a lot. The ones that have 1 term, 2 terms, and 3 terms. We call those monomials, binomials, and trinomial. Mono is a prefix for the word 1. Bi is a prefix for the word 2, like a bicycle has 2 wheels. Tri is a prefix for the number 3, like a tricycle has 3 wheels. So we have an algebraic expression with 1 term. So here's an example, 5x squared. It's a single term. Binomial is an algebraic expression with 2 terms. So it's going to have 2 parts, and it's going to be separated by a plus or minus. So here's an example, 6y squared, first term, plus, beginning of second one, 7y. And a trinomial, same thing, but now we have 3 terms. So here's an example with 3 terms. So x squared is the first, positive 8x is the second, and negative 4 is the third. Again, make sure you're pausing the video to write this stuff down. And the last 2 things we want to focus on is the degree of a term and the degree of a polynomial. So the degree is the exponent, and the degree of a term, each term has its own exponent, and the polynomial has a degree altogether, which would end up being the highest. So again, the exponent of the term is the degree of the term, and the degree of the polynomial is just the highest exponent of any of the terms. Usually it'll be the first one if it's in descending order. All right, let's go ahead and just look at some quick examples of what we're going to be doing, which is pretty much combine like terms. Again, if you have the same variable and the same power, you can add and subtract these terms by combining them. So like 5x and negative 8x, you can combine them. They both have an x. They're both variables, terms with variable x. Same power. 7y squared plus 23y squared. Again, you can combine these as well. They both have a power of 2. Here's some non-examples of things you cannot combine. 9x and negative 3y. They don't even have the same letter, so you cannot combine those 2. Not the same variable. 7a squared and negative 7a. They have the same letter, or variable, but they do not have the same power, so you cannot combine these two. So not the same power. All right, so let's look at a few more examples. Again, when I talk about combined like terms, I might just abbreviate with CLT, and I write it down. So again, like terms can be combined to form a single term or a shorter expression. So as we combine things, we simplify. We make it less written work and makes a shorter polynomial for us to write out. So again, it simplifies an expression for us. So let's go ahead and look at example number 1. Let's get out of here and let's go to the actual notes. So I'm going to go ahead and do examples numbers 1 through 6. So let's look at example number 1. So we have two polynomials being added. Again, the reason I know they're added is because of this plus sign in the middle. And these are specifically two trinomials. It's got 3 terms and 3 terms. So we're adding two trinomials. And the idea is we're going to look at the terms that are the same. So I'm going to take my 5x squared. I'm just going to rewrite this. And I'm going to combine it with, actually, let's make it simpler. Let's take our 5x squared. I'm going to underline it. And this one combines with the 4x squared. Now, I do have these parentheses. So I'm allowed to drop the parentheses. I'm going to rewrite the exponent. The reason why I'm allowed to drop these parentheses is because there is nothing outside these parentheses that indicate multiplication. So I can just drop these. Later on, you'll probably skip the step. And we're going to go ahead and combine 5x squared and 4x squared. And 5 and 4 are the coefficients, and those give me 9 when I add them because they're both positive. Now, the one thing to remember is the exponents do not change when you combine. We're not combining, we're not multiplying the x's. That's when we would get x to the 4th. We're just adding or subtracting the coefficients. That is it. Nothing else changes. Now we're going to go ahead and combine the next set, which is a 3x with a negative 3x. These are like terms. They both have the letter x. So let's combine the numbers, 3 minus 3, which gives me 0. So these technically eliminate. So these are gone, actually. So we don't need to worry about those. And then the last one, the negative 2 with the negative 7. These are just regular old numbers. We combine them as usual. Negative 2 and negative 7 give me negative 9. So when I added these two trinomials, I ended up with a binomial. Let's go ahead and move on to number 2. So this one, I do have a number on the outside. So before I start combining, I need to actually distribute that 2. So I'm going to go ahead and multiply by 2. So that's going to give me 10a squared plus 14a minus 4. This is subtraction as well, so I need to go ahead and distribute that negative. So when I distribute a negative, it's multiplying by negative 1. You can always think of it as us having an invisible 1 right here. So let's go ahead and multiply by 2 and then by negative 1. So when I multiply by negative 1, I get negative 3a squared, positive 8a, because we're multiplying two negatives, and positive 10, because negative 1 times negative 10 is positive. All right, let's go ahead and combine our like terms. A squared with the other a squared combined. Their coefficients are 10 minus 3. That gives me a 7. A squared. Only the number in front, the coefficient changes, not the exponent. 14a combines with the other a term, 8a. We add them and we get positive 22a. And then the last two terms, the 4 and the negative 4, I should say, and the positive 10 gives us positive 6. And again, we multiplied a trinomial and then subtracted it by a trinomial, and we got another trinomial. All right, let's look at the next one. We have 3. Here we have a binomial subtracted by 2 multiplied by a trinomial. So we're going to go ahead and start by dropping the parentheses in the first one. There's nothing out here. So we can just leave it as negative 7y squared plus 8y. On the second one, we have the 2 that we have to distribute. I should say the negative 2. So we have negative 24y minus 3y squared plus 6. So when we multiply Nope, that's a mistake. 2 times 3 is 6. And 2 times 6 is 12. Sorry about that. So again, make sure I multiply by 2 and by the negative as well. Now I'm going to combine like terms. The y squared combines with the other y squared. They're like terms. Like it's going to give me negative 7 and negative 6 gives me negative 13y squared. I'm going to combine the 8y with the 24y. That's negative. So we're going to subtract these and we're going to get 16y. That's negative. And the 12 just kind of doesn't combine with anything. There's no single term anywhere else, so I just drop the 12 at the very end. Stays positive. Doesn't change term or value. All right, let's go on to the next one. We have our trinomial minus another trinomial. And since we're subtracting, we have to make sure we distribute that negative. So we have 5x squared minus 6x minus 7 minus 4x squared. Again, distribute the negative, which makes the 3x negative, makes the negative 1 positive. So always distribute first, then combine. So like distributive property, combine like terms. Those two always go in that order. 5x squared and 4x squared combined gives me 1x squared or just x squared. You can put the 1 in the front. I'll put it in yellow. Or you can choose not to put it. That's kind of your call. Then the 6x squared, I'm sorry, the negative 6x with the negative 3x combined, that gives us negative 9x. And the negative 7 with the positive 1 gives us negative 6. And we're going to do with that one. Let's go and move on to the last two. All right, next one we have this binomial that needs to be multiplied by 2. So let's go ahead and multiply by 2 before we combine. So we're going to multiply by 2. So we have 2y plus 18. The second one, there's just really an invisible 1 here. So nothing really happens to it. So we're going to keep it as 8y squared minus 3y plus 9. And just go straight into combining like terms. Now, I'm just going to put them in order. So if you don't do it this way, that's fine. But I'm going to put the higher power first, which is 8y squared. There's no other y squares. So I'm going to put that one first. Then I'm going to put my y terms, which are just these guys. That's going to give me negative 1y. I'm just going to put negative y. The 1 is optional right here. And then lastly, we have our 18 and our 9. And that's going to give me positive 27. And I'm done with that one. So distribute, combine. Sometimes you may not need to distribute anything if it's all positive. All right, last one, we are combining two trinomials that are being multiplied. So distribute first, and then combine. So multiply, then add, subtract. It's order of operations right there. That's all it is. So multiply by 10, 10d squared minus 50d plus 20. Multiply by negative 11, so it's negative 22d squared plus, because it's two negatives multiplied, 33d minus 11. Combine like terms, powers of 2, negative 12d squared, which is regular single variable. Subtract, one's negative, one's positive, negative 17d. And then the single numbers, that's going to give me positive 9. And that's the general idea. So always distribute if there's a number on the outside. If there's no number on the outside, you won't have to worry about it. Just combine like terms. If it's negative, don't forget to switch signs by distributing the negative 1. And go ahead and do page 1 of your practice.